Intelligent Machine Monitoring number 14. Today we have Christian in our studio, and he will give us a tutorial on how to detect liquid carryover in reciprocating machinery. Enjoy.
Yes, hello everyone. Today we speak about liquids passing through reciprocating machines. This is a problem which is very dangerous for these machines, and therefore it's always a question: how can we detect such a problem in a running machine before we have a large liquid slug which would damage the machine strongly. So what are the parameters we should look at in order to detect small portions of liquids going through a cylinder? We have here on the board a diagram which shows here the one revolution of our reciprocating machine. We have top dead center, bottom dead center, and top dead center. And then here you can see how the measurement is actually reading over one rotation. We have a vibration measurement on the crosshead slide. We have here the one revolution of the rod position. And we are showing here the two curves of the crank end and head end side dynamic pressure over one rotation. Now these parameters are all important, and we will see in a second picture how they are affected if small portions are going through. In the good situation, which you can see here, everything is normal. We have a smooth movement of our piston rod. We have smooth vibrations, and our PV diagram looks absolutely normal. Okay, in the case that liquids are in our cylinder, what will happen? We can see a change in our vibrations, which would look something like this. And we would also see a change of our piston rod, dynamic piston rod movement, which would be then actually not anymore this curve. Instead, we would have something like this. What we would also recognize is that our PV curves remaining in the same way as they have been before. So what do we see here? We see high vibrations in the last part of our revolution. Our piston is moving from top dead center to bottom dead center. So we see here, this is the moment when we are compressing the gas at the crank end side of that cylinder. And this means we have a high pressure or an increasing pressure inside. And in the moment when we start here with the discharge of our gas, in this moment we can see these very high vibrations, and at the same time also a big movement of our piston rod. Now, how is this connected? What we established, or what we have found in the past, is that we are compressing the gas. There is some fluid in the bottom of our cylinder, and when we are coming closer to bottom dead center and to the point of discharge, the pressure on this fluid is getting high, and in the same moment some of the fluid is actually going underneath our piston, lifting the piston up, and this is what we see here with our rod position measurement. The piston is being lifted up for the rest of the revolution. At the same time, we have high vibrations, which are because some of the fluid is passing our discharge valve, and also our piston is not nicely guided anymore by our crosshead, because it's floating, so there's a lot of vibration created by that. And what we can see then, when the pressure after the bottom dead center is decreasing again, everything comes back to normal. Now, to detect this effectively, you need to monitor every single revolution, and you need to have an automated way to detect different changes in different locations of your rotation. This is important because this is happening maybe in the middle of the night, and only for very few revolutions. So a small portion of liquid is going into the cylinder, then it's going through maybe 10, 15 revolutions. This small portion is being pushed through your discharge valve, and then everything is back to normal. So it is hard for anyone to realize that there's a sufficient problem coming up, and we can all imagine if this liquid builds up to a higher volume inside our pulsation damper, for example, then at some point a large volume of liquid can pass into our cylinder, and then we get a real liquid slug, which would then create a real massive mechanical problem in our machine, which may even lead to a complete loss of that machine, or at least of that cylinder. So modern systems can detect these kind of things inside such a machine at an early stage. So when we are passing small portions of liquids, and then there can be taken action to look into our piping or in our pulsation damper to find if there's high volumes of liquids there, and then releasing these liquids more frequently in the operation, and this will then save the machine to really see such a dangerous liquid slug.
May I ask a question here? What worries me a little bit is that the signal for the rod position goes up. What worries me is because the measuring sensor sits above, so the measuring value itself should go down and not up. How does this come?
Yes, thank you for that question, Joost. You are absolutely right. The normal measurement position is top down on our piston rod in order to prevent debris or anything else
sitting on top
of our sensor, and then changing our measurement. But for the understanding of our mind, it's because we say if the piston is moving upwards, we want to see a positive signal. The signal can be switched or mirrored inside the software, so you can see the signal in this way. So that's the only...
It makes sense in terms of usability for the customer and the user. Well, thank you very much for this. I find it very interesting. A lot of sensors are here needed to have a proper detection of this liquid carryover. I would like to recommend one of our earlier videos where we talk about what is a good instrumentation scope for reciprocating compressors. Maybe you get some learnings from this to see if your compressor is properly installed with all the measuring points that are needed to detect liquid carryover. Thanks again.
Maybe one thing.
Yes.
There's one more thing. There's one more thing. We should not forget, and I actually forgot to explain this before, but I think it's important. What you've seen, that I changed two of the parameters. I changed the vibration and also the piston rod movement, but you saw I did not change anything on our PV diagram. And this is surprising for many people, that the PV diagram is not affected by small portions of liquids going through, and the reason is that the gas pressure remains on the same level. There's no influence just because there's fluids instead of gas. Still, the end pressure and the movement of the pressure remains the same. I just wanted to add that, sorry.
Okay, all right. So this should be it for today. Stay tuned. See you next time here at Intelligent Machine Monitoring.
Thank you very much.